Hello. Hello, welcome everybody to the fourth Serverless Belgium Meetup. Still online due to the COVID crisis. So I will quickly go over the agenda and then give the word to our first speaker, which is Frédéric. And he's going to talk about an event-based serverless traffic application that he has built. When he has finished the talk, we will do a Q&A right away, and then we will take a short break. And then we have our second talk for this evening, which is given by Nick, and he's going to talk about Amplify. And then we will do a second Q&A and do a wrap up. So yeah, I can give the word to Frédéric now. So Frédéric, it's all yours.
Hello everyone. Thank you very much, Kurt. Thank you, Thomas, for hosting me tonight. Let me share my screen and let's start the presentation. Okay, so thank you everyone for joining. I'm Frédéric. I'm a tech leader in the Theodo, and I'm the head of the serverless tribe since 4 years now. And today I want to share with you the learnings of an event-based serverless application we had to develop for a client, broadcasting real-time traffic alerts. This presentation will focus on the development of an application using the serverless framework, all written in TypeScript and using AWS as a cloud provider. First, a bit of context about our client for this development, RATP Dev, a subsidiary of RATP. RATP is the network operator of Paris network. RATP Dev actually handles the operation of networks outside of Paris, everywhere around the world. For example, in other cities in France, like Brest, Angers, or Valenciennes, but also worldwide with Casablanca, Manille, and actually has to transport 1.5 billion passengers per year. Despite targeting an excellent service record, transportation networks can sometimes be disturbed, thus leading to service interruption, delay, and route changes. When such a planned or unplanned event occur, it is crucial to ensure that commuters are notified as soon as possible, giving them the opportunity to adapt to the situation and find an alternative solution. However, nowadays, many communication channels are available for the different commuters, and they all have their preferred one. For example, for the simpler network, we always have a web and mobile application of the network, Facebook groups, Twitter accounts, Google Map itineraries, and sometimes notifications through email and SMS and push notification. For the operator to actually broadcast a message across all these various channels, before Theodo started working on the solution, he actually had to switch between all the various interfaces of this different system to send the same message across. This was very time-consuming and very prone to inconsistency between messages across the various channels. So we developed a product called Notify, aiming to make the life easier of the network operator, allowing him to broadcast efficiently and consistently message across commuters. So why did we choose to go with a serverless solution for this application? First was our client context, without any development and ops team on board. And he wanted to minimize as well as possible, as much as possible, the need for a specific team to run the application, requiring no internal ops in RATP Dev. Since most of the run operation we had to do on the application are mostly code-based operation, serverless seemed like a good fit. Second point was the particularity of this application. As I said before, the disruption events are unpredictable and necessitate a very high throughput of the system whenever you need to broadcast a message across. Finally, we are connected to many various third parties through HTTP API, answering asynchronously to the different requests we give them to send message across, making the serverless paradigm a good fit for this application. During this talk, I will go through 3 different points. First, I'll go back quickly on what is event sourcing and common query responsibility segregation. I will go a bit deeper into this pattern to make you understand the benefit of using them in an application. Then I will go specifically on the implementation of such pattern on AWS using the different managed services available. And finally, I will go through the different pitfalls and drawbacks that we face during the development phase of the application and the solution we found to counter them. Let's talk first a bit about event sourcing. So what's the point of event sourcing? Event sourcing is an ID, a storage paradigm, storage pattern, where instead of storing the application state at all time, you will persist events representing a transition of application state, ordered in a timely manners and immutable. Basically, if we take the example of an accounting system with 2 accounts, every time you perform an operation on each of those accounts, deposit operation or withdraw operation, you will add to your audit log, to your event ledger, your storage layer, those events at the time they occurred with some attributes, like, for example, the amount of euro you deposit or withdraw. This kind of audit log of event sourced stored system allows you to specify a point in time at which you want to compute the state of the system. For this example, if we want to get the balance, which represents the state of the system at a given time, on the 12th of March, we will actually go for account 1 through the 2 events, deposit 100 euro and deposit 50 euro to get the balance of 150 euro. And for account number 2, only 1 event on the audit log, which is a deposit of 300 euro, accounting for a balance of plus 300 euro. Event sourcing is not a new thing, is not a new pattern for web application development. It has been around for quite some time now. Like we see for this example for financing account, but for accounting as well, accounting operation are an event sourced system. But for health as well, for example, where your medical records consist of various inspection reports of your current health state, rather than every time doctor come to you, removing all the previous reports that were inside your medical record and putting the last one corresponding to your current medical state. Same thing goes for logistics, where your package, when moved around the world, actually records precise events, departure of a warehouse, arrival at an airport, departure for delivery, rather than persisting the state of all the packets around the world for this specific logistic operator. By the way, the go-to solution for event source system as a persistence layer is our good old single writable CD, which is equivalent to what we call a warm drive. Warm stands for write once and read many. It's very important that your audit log, that your event ledger, where all your events are persisted, is immutable, that you will never actually change them. Another very important point in an event source system is to split your events and making sure that all your events allow you to compute the state of the system. If you take an event source system, compute a state, remove the state and recompute it from all the events and arrive to a different result, it means that some information that were in your state before didn't came from the events in the audit log. Another thing to pay attention to is the granularity of the event that you put in your audit log. For example, here you have two states, state A at one point in time and state B at another point in time, which actually states the quantity of line affected by an alert. There are two paths represented on this diagram, one going through a single event added to the audit log, saying that line 4 is now also affected by the alert, and another path where two events are stored on the audit log, one saying line 4 and 5 are affected, and another one saying line 5 went back to normal. When playing those events from both those audit logs independently, you actually arrive to the same state, which is an alert on line 2 and line 4. However, you are losing some information if you only persist the first pass in your audit log, since you miss the information that line 5 was at some point affected in time by the traffic disruption. If you want to know a little bit more about event storming, the practice where you actually split your domain into events, I recommend this very good talk from Ben Ellerby at Theodo UK, which actually is a serverless hero, who made a full talk about actually building the different events constituting your domain. With event sourcing, the pattern I just described, you have three advantages straight out of the box. First one, since your audit log is your single source of truth, all the states that you use in your application can be discarded and fully rebuilt at any time, replaying through all the events in your audit log. This is very important and a very nice feature for development team, since you can take the audit logs from one system in one environment and actually put it in another system, for example, a development stage system, where you will rebuild all the events with a different code base. Another very good advantage of the event source system is the fact that you can do temporal queries, meaning that if you want to know the quantity of alerts that were active on a specific network at a specific time, at a specific date back in time, you can play all the events of your audit log up to that point in time, stop there, and observe the state of your system. Final advantage of an event source system is the ability to do event replay after event modification. So if you have a bug occurring in production and the user actually calls you and say, okay, here I'm seeing something I was not expecting, you can recover the event ledger, the audit log of your production application, replay it locally, find a fix, and then modify the event affected by your fix to replay all your audit log and see if the computed output state actually does not have any more the issue the user was calling for. So it's very practical for solving bugs occurring in production system and testing what would be the outcome of having such code in real use case that happened in production. Before we go to the concrete implementation in AWS, let's go to the final part or the final pattern of this application, which is common query responsibility segregation, which works very well hand in hand with an event source system, where you split your commands model and your query model. So all the things that you do with your application that will affect somehow the state of your application, called commands, and all the things that you do with your application that does not have side effects, that does not update the state, the queries. For example, on an application, having a page where you list all the alerts occurring on the network would be considered a query, whereas when a user actually asks for the broadcast of a new alert specifying disruption of service on line 2, this will be considered as a command since you will be affecting your application state. Command will actually go through business validation using the previously stored event related to this specific entity, this specific aggregate, for example, an alert, to validate that the new command you're trying to run is valid, insert it into your audit log, And this audit log will be the source of update of your projection of the actual state of your system that will be here to facilitate queries by having all the information specifically related to a single query in the same location without requiring some recomputing. The link between your audit log and your projection is the projectors that will actually reduce the event from the audit log down to the model that you use for your query with all related information. I'll go a bit deeper about this when I'm talking about the AWS implementation. So, working with AWS on this one, I want to share with you specifically 4 different managed services that we use to develop this application. First one is API Gateway. API Gateway is an HTTP endpoint managed services, allowing us to do easily routing of HTTP requests to other dedicated managed services in AWS. API Gateway also has a nice set of features allowing for input validation before you actually trigger any downstream managed services in your stack. So you can input JSON schemas to say that you expect this field and this field on this specific request. And API Gateway will be able to respond with an error code, an HTTP error code back to the user if the HTTP request does not meet those requirements. Finally, API Gateway was also used in conjunction with Cognito, managed services from AWS for managing user, to ensure all calls made to the backend of the application through API Gateway were authenticated calls from users registered on the application. Second service I will talk about in this presentation is Lambda, which is a function as a service managed services from AWS that will be triggered by various events, like the one from API Gateway that we saw just before. Then DynamoDB, which is a managed NoSQL database. One feature that we will particularly use to leverage CQRS and event source pattern of DynamoDB is DynamoDB streams. I will talk about it a bit later. And finally, to glue it all, we use EventBridge, which is a pub/sub managed services, behaving like an application bus that allow all these different layers to communicate easily in a decoupled way. Another nice feature of EventBridge, since I was talking a bit before of the quantity of third-party integration that we had to do on the project, is the fact that AWS offers integration straight into EventBridge for some SaaS application, allowing easily to respond to some event occurring on another system without requiring the implementation of the classic schema, of the classic pattern of webhook calls made through HTTP protocol. So with all those different blocks, let's take a look at the first event source serverless architecture that we can put in place. So on this diagram, you can see API Gateway used as a router to split all HTTP requests that are commands to the up part of the schema, and all the HTTP requests that are queries down to the Lambda on the bottom of this diagram. If we follow the command line, we see that we have first layer of Lambda actually processing business validation before inserting a new event in DynamoDB, the event ledger on the upper right corner. Those Lambda will actually, in the first stage, recover and build the aggregate used for a specific entity. So for example, if we take back the example of Notify application, one aggregate is what we call the alert aggregate, which enclosed all the events related to a specific alert. The time you create it, when you add lines to it, when you add description, when you add broadcast channel you want to broadcast it to, when you request the broadcast of this alert, when you request an update broadcast of this alert, and when you close it. All those various events are related to the same alert aggregate. Whenever you run a command for a specific alert, for example, closing an alert, the specific Lambda will be triggered by API gateway based on the routing of the HTTP request. And before this event is inserted as a new row in Amazon DynamoDB, the Lambda will build the state of the current alert impacted by this close command using DynamoDB existing event on the audit log to build a state temporarily and check if it is in fact allowed to play this close event or not. Once the event is inserted inside DynamoDB on the audit log, projectors, which are dedicated Lambda, will be triggered to update models on a separate DynamoDB table called projection table. Basically, when, for example, you project the alert closed event inserted into the event ledger on a projection which is used, for example, for the detail page of the alert, your projector will actually change the attribute status of your projection for the detail page from ongoing to finished. Finally, Lambdas on the bottom part of this schema query will query in DynamoDB the line requested for a specific page of your application, for example, the detail page of your application, and you will have the updated status of your application inside those projections. Please bear in mind that even through the fact that we have two DynamoDB, only the top right DynamoDB containing your audit log is the single source of truth of your application. Projections are disposable by nature and can never be relied on to know specifically the state of the application. Let's take a closer look at what we can find inside those two DynamoDB tables. First one we look at here is the event ledger, the audit log. What we will use to make sure we can easily write new events and build aggregates for the business validation of the command Lambda is to use a composite primary key. This composite primary key is made of a partition key and of a sort key. In order to be able to easily query all the events related to a same aggregate, we will actually use a single ID generated when the first event occurs at the first command of a new aggregate, for example, the alert creation command, as a partition key. Having all the events subsequently inserted relating to the same aggregate on the same partition will allow us to run a DynamoDB query on an exact match of the aggregate ID with a scan index forward to make sure they are ordered through the sort key, and making sure that we have no gap in the version inside our sort key. The version that is used as a sort key is an incremental number showing, making sure that we have no concurrent insertion of two events in the system. So for example, if you have two commands Lambda running at the same time, trying to update the broadcast and close a specific alert, they will try both to write a new event with the same version number. And since we put a condition on the version that we try to insert in DynamoDB, stating that this version should not already exist, only one of those two put item called to DynamoDB will succeed. You have at the bottom of this page a small example of what our table for the event ledger, for the audit log, will look like, with two separate aggregates, one of them with two events, and the other one with a single event. Now let's take a look at our projection DynamoDB schema. So the bottom right DynamoDB table on our first schema, where you actually have a disposable projection representing the state of the system specifically designed for the various queries that you want to answer to. Inside this table, we will use as well a primary composite key. The partition key will contain the projection name, the specific query that this item will be used for, and the sort key will contain the ID, the aggregate ID that was used on the previous event ledger table. When you want to recover a specific projection for a specific item, for example, the alert detail for the alert of ID 12, you will actually use a get item on this composite key with a projection name equal to alert detail and a sort key equal to 12. When you want to recover listings of projections, for example, for a listing of all the alerts, you can use a DynamoDB query only requesting an exact match on the projection name. So for example, if I have a projection alert list with only the attribute required for the page listing all the alert, I will ask DynamoDB to recover all items inside the partition name alert list. I have the availability to do filter on the listing I want to recover using local secondary index. For example, if I want to recover all alerts for my listing only occurring on the Brest network, I can specify another key, network, of my table to be used as a local secondary indexed with the partition key and require that I only query the row of this table with the projection name of list alert and with the network equals to Brest. Another very important thing to take a look at in an event source system is to make sure that you have a fallback, an error handling chain in everything that is asynchronous in your system. As we saw together, whenever a user wants to play a command on this system, like the creation or the closing of the broadcast of an alert, it will be routed through through API gateway down to the AWS Lambda command and inserted into DynamoDB, into the event ledger. When this is done, the command validation Lambda will actually respond to API gateway to let the user know that his command was successfully inserted into the audit log. Everything after the event ledger, down to the projection table, is asynchronous and can sometimes misbehave. In order not to lose any information that could make the projection out of sync with what we actually have inside our audit log, it is very important that we have this error handling chain on the projectors and on the fan out, actually putting all messages that could not be used to update projection inside the dead letter queue, a simple SQS queue, where we can find all the defects of the application. Compared to the previous schema, you can see on the top right corner two additional things that were not there before, the fan out and the EventBridge. This is actually necessary for event source system, since everything that has been inserted in the event ledger, all the events that we add to our audit log, can be streamed using DynamoDB Stream to downstream services, but only up to 2 different services. So we actually put a fan out Lambda that is only job is to commit what has been inserted into DynamoDB into EventBridge, into our application bus, so that as many projectors as possible can register to this specific event being inserted in the audit log. There is not only projectors updating projection inside our system. Updating projection is just making sure that subsequent queries that will be done to the system actually fetch information up to date with the audit log. But for the actual work of the application, let's say, for example, call the HTTP API of Twitter to broadcast a new tweet, you also need a specific Lambda called handlers that will react to the same event insertion than the projectors to actually execute business logic for the application. This split is actually quite nice, since we have all the process selection logic dedicated to EventBridge and all the processing specific logic dedicated to the projector or the handler. The fan-out lambda, the one between the audit log DynamoDB and the event bus, its only job is to take events being inserted in DynamoDB and publish them into EventBridge. And doing so, it can use specific element of the event inserted to put it in specific property of the event published in EventBridge. For example, it can use the aggregate name that the event was inserted for and put it inside the source property of the event that will be published in EventBridge. Same thing for the event type and all the payload concerning this specific type of command that has been inserted into the audit log. The projector and the handler, through the definition of the serverless framework, will only trigger for their specific events that they want to react to. A projector, which job is to update the alert detail projection for the event of alert closing, will only be triggered whenever there is an event inserted in event bus where the detail type is equal to alert close. Same thing goes for the handler, that can only be triggered whenever they have a specific job to do for a specific type of event that has been inserted into the audit log. To conclude this talk, I will go through 3 different drawbacks that affect event source application and specifically their implementation in AWS. First drawback is what we call eventual consistency. Like I told you before, the first part of the command playing of the system is synchronous from API gateway through the AWS Lambda handling the command validation and up to the DynamoDB used as an event ledger where all the events are stored. This is synchronous since the user using the application will actually wait for an answer from all these 3 different services before actually saying, okay, the call was successful or unsuccessful. However, the remaining part of the chain where the fan out, the event bus, the projector, and the updated projection inside the remaining DynamoDB table, all those operations are asynchronous and will happen at a later stage. Most of the time, it will happen very fast. However, during a certain time frame called the inconsistency window, the system projection are out of sync with the event ledger of the application. There are 2 ways to cope with this situation. First of all, for the user to improve his experience, we actually implemented optimistic update, meaning that on the front-end part of the application, whenever a call for a command validation was successful, the resulting operations that should have been shown on the user interface were already displayed as if the projection was already made. In case the projection did encounter some problem, we also implemented some WebSocket system actually registered to the projections table, streaming all the updated projection to the client interface, making sure that if eventually something bad happened and the projected state of what has just been played by the user is not the one actually happening in the backend, the information can be updated in real time for the user in his interface. Second problem, the second thing to avoid that we tried to do at the beginning and run away from during the project was to be tempted to not use an aggregate reconstitution inside our command validation lambda, but to use directly the projections that were available in the projection table. This is actually breaking one of the CQRS pattern principle, since we have actually something in the command side of the system relying on something on the query side of the system. And this is very dangerous, especially because, like I said before, projections are disposable. Whenever one page of your application change or is not available or is not there anymore, you actually modify or deletes the associated projection. If your command validation lambdas depends on those projections, you have a risk of actually making a command validation lambda fail because you removed or modified a projection model, a query model. So make sure that whenever you're running business validation in your command lambda, to recompute the aggregate state only from the event inside the audit log. Finally, one final drawback of using event source system was the observability, consequently being degraded by the fact that we have many interfaces in place in the system. We tried to rely on AWS X-Ray, which is a dedicated service for observability through various layers, through various managed services, allowing you to easily trace from the HTTP request down to the command lambda, down to the DynamoDB layer for the audit log, and then to the projectors, handlers, and projections. This would have been perfect. However, X-Ray is not supported. X-Ray is actually only inserted a correlation ID used inside the event, triggering all your various parts of your architecture. And those correlation ID are not passed along in all the services. They are not passed through DynamoDB when something is inserted so that you can actually follow what is being consumed downstream in the DynamoDB stream. And they are not passed through inside EventBridge. In order to cope with this missing feature, very useful for debugging why this specific projection updated in such way, we actually had to implement a correlation ID by hand, both in DynamoDB and EventBridge. Thank you very much for your attention. This was quite dense. I hope you have a lot of questions, and I hope as well I will be able to answer them. Thank you very much for your attention.
I actually don't see any questions yet. So it was a very interesting talk, Frédéric. It's a lot to ingest. So maybe I can ask a question because I find the pattern very interesting. But where I struggle a bit with, you say the projections are disposable, which I understand, and they are asynchronous. But they are kept in sync with a Lambda. If I understand well, if that fails, that event is put on a dead letter queue. But isn't that then a real problem? Say the Lambda is just failing all the time, then the projections get out of date. Will the user then see that? How do you cope with those things?
Yes, for sure. If your Lambda is actually failing to update a projection and all the events that were supposed to be consumed by projectors are actually ending up in the dead letter queue, your system will be out of sync. So for example, a user will create one alert, and when he goes back on the listing page of all the alerts, he will not see the latest alert that was normally inserted into the system. Having those events inside the dead letter queue allows you to actually put a CloudWatch alarm, watching the quantity of item in this queue, and react quickly whenever there is a projection that cannot occur. But when you actually go on your application and fix the problem that was affecting your projection Lambda, there is no problem running back the system without any loss of information, since your audit log is containing all the events that has been required, that has been asked by the users. And since your projections are disposable, you can delete everything that you have in your projection table and rerun inside, basically re-put inside EventBridge all the events that are inside your audit log, re-triggering your projectors and making sure your projections are again in sync with your audit log.
Okay,
Does
cool.
that answer your question?
Yeah, that answered my question. I've another, somebody asked, what is the cost of implementation in AWS? Do you have
we run the system for a few months now, and we stay below the €10 mark every month.
Okay, cool. Another one I see, is this architecture run in one region or is it a multi-region setup?
It's a single region setup.
Okay.
Only a single region.
Okay. Maybe one for myself also is like, yeah, they always say CQRS is very nice, but it comes with a lot of overhead. Like, yeah, you have asynchronous things. Was it something which, yeah, you had estimated correctly in the beginning, or was it like a lot of overhead or a lot of complexity was added which you didn't foresee?
Complexity for sure there is, but unlike traditional system where your complexity will actually rely inside your code base, we actually shifted this complexity down to managed services, discussing between them and making sure that they are correctly piped together. So the complexity that was before inside a code base that could be tens of thousands of lines was actually shifted to a service definition of the serverless framework, saying that you should have 2 DynamoDB tables, saying that you should have a stream going to a fan-out lambda, and the complexity was subsequently very much reduced inside the code base itself. The code base of all the different projectors, command validators, handlers, query lambda and command lambda is actually very simple. It's only a few lines every time, and it's very modular as a system. For example, you have a new page, you need a new projection, you need a new command, you need a new query lambda to query those updated projections. You actually need to write code for 2 lambda and deploy them in your application, and everything is working like it's supposed to do. You don't need to run a new application bus, to run a new queue inside the RabbitMQ. You don't need all this overhead, all this complexity overhead. So putting the system in place in the first weeks of development, making sure that everything was piped together correctly for the first events and the first projections was a bit complex. But after that, the remaining part of the project were much more simpler.
Okay, cool, thank you. Another question, how do you catch your Lambda failures in SNS? Do you use Lambda destinations for it? Or when items arrive on your DLQ, how do you re-trigger them?
We do use Lambda destination whenever there is a Lambda failing more than 3 times. And on SQS, when we have an event actually failing, the information inside SQS is not something that is lost from somewhere else. The things that you end up having inside your dead letter queue are actually copy of what is inside your DynamoDB event ledger. So what you need your SQS for, actually we could have only spare an SNS, is just something to show that there has been a problem on the system and to trigger an alarm. But the content of the message inside SQS is not relevant other than actually figuring out which kind of event was not properly handled by the system. The event itself that we want to replay after actually deploying a fix is already inside DynamoDB. And since we recently have a new feature from EventBridge since reInvent, which is called basically replay, the replay feature, you don't even need to retrigger something from DynamoDB to force an insertion in the DynamoDB stream through the fan-out lambda down inside EventBridge and down to the various projectors and handlers. You only need inside EventBridge to say, okay, I want to replay events from this date where the bug occurred. And since all your projectors are idempotent, you actually end up with projection up to date, fixed by your recent deployment of the fix.
All right. Thank you. Maybe a last question. What was really the incentive to go for event sourcing? When you have different database, sometimes it's like it makes sense to separate those because your reads are a lot heavier, so it's better to just separate those two. Or is it just because event sourcing works quite nice with CQRS? Yeah, I'm just wondering why you picked that kind of architecture, or the replayability, maybe.
First of all, I think the first thing that justifies using a secure system here is that your command to the system, the specificity of the application is to broadcast alerts. And to do that, you need to communicate with a lot of different API third parties through HTTP that will most of the time acknowledge your request and come back to you later when they have actually broadcasted the message. Most of them are asynchronous. So we figured out that our system was actually a lot of different commands, both from the user interface of the system through the web application, but also from different third party coming back to us saying, okay, this alert has been broadcasted by email to the requested user for this specific event. Since we didn't want to have many multiple sources of information trying to update the same model and using the same model for the read also, using SecureS to split this concern and actually having an audit log with everything that happened on a single alert and a projection model which are perfectly fitted for the different page of our application made a lot of sense. And actually, we are quite, today, we are quite satisfied by the way the system behaves. Most of the work is done asynchronously, and we didn't want to have actually model like we do in a CRUD application where you use the same model for the update and the same model for the read. We wanted to be able to store everything that was happening. Final point that made us go for the secure system is that our clients want to be able to download an audit log of what happened on the system, who did what. And rather than keeping separated trace of an history of everything that happened to the application, plus a single model both for read and write operations, we thought that SecureS was a go-to solution.
Cool. Thank you very much, Frédéric.
Oh, my pleasure. It was really nice. Thank you for the invitation.
All right, so I guess Nick is ready to give the next one, which is about Amplify. So Nick, if you're ready, I would say go.
Go over my learnings from building an AWS Amplify application for production, learnings that made me stronger and learnings that will hopefully make you stronger in the future as well. Now, we will start this talk as we will end it with the takeaways, with the content. What are we going to see today? That is, first off, we will see how to set up an Amplify application across multiple environments and even across multiple accounts. So really a production-ready setup. Then we will go into how to use AWS Amplify in a CI/CD pipeline to automate deployment. Next, we dive a little deeper into the API service, the AppSync service, where you can build a GraphQL API on top of your data sources, namely DynamoDB and AWS Lambda. And then next, but not last but not least, I already mentioned the Lambda functions. We will see the art of configuring a Lambda function correctly with AWS Amplify. And then I'm talking permissions, environment variables, Lambda layers, calling your own AppSync API from within your Lambda function, and error handling. So please join me upon this journey across the wonderful world of Amplify. Please join me at ServerlessDays Belgium, February 24th, 8 o'clock Central European time. See you there. So briefly, who am I? I'm a serverless evangelist, self-declared, that is. I'm also the co-founder of TransIT, which is the company that makes next level software for the transportation industry. And on a personal level, I am a coffee addict. I'm also a speaker on many serverless conferences in the past, but also in the future. In April, you can see me at work at Serverless Architecture Conf Den Haag. And if you want to follow me, it's best to do it on Twitter and get in contact with me there. I'll be happy to answer all of your serverless questions. All right, let's get on with it. So Amplify, what is AWS Amplify? Amplify is a full stack serverless framework to build applications with AWS technology. That is the best one-liner out there to describe AWS Amplify. Now we are going to build an application with AWS Amplify. So please join me upon this journey and meet the team that will build this application for us. Within our team, we have we have Nick, myself, we have Karen, and we have John, because every team needs a John. And we have an AWS organization within which we have multiple AWS accounts. So we have a dev account, test account, a production account. So really a production ready setup to separate environments and to separate the dev, the test, and the production environment on multiple accounts like you should. Now, what are we going to build today? We're going to build a quiz application which you can also actually really play on serverlessdays.be. So it's quiz.serverlessdays.be. Okay, we're going to build this with AWS Amplify. And what is AWS Amplify? AWS Amplify is a Swiss Army knife. It's a multi-headed service. For me, there are 3 important pillars. There are probably more if you ask someone else, but these are the ones most important to me. So on the one hand, you have the JavaScript libraries, which you can use within your code. Then you have the Amplify CLI, which you can use to build CloudFormation, to speed out CloudFormation, to build cloud services in your cloud account. So it's really infrastructure as code. And then you have the UI components that you can use in your front end. Now let's dig a little deeper into the Amplify CLI, which you can use to configure cloud services. For example, you can configure S3 buckets, and those S3 buckets, they belong to the category within Amplify, the category storage. So within Amplify, everything is divided from your backend. Everything is divided into multiple categories, like storage, like API, which can be a GraphQL API, which is AppSync, or which can also be a REST API if you want to. You have the auth category, you have the functions category, you have hosting, you have many more, but these are the ones most important to us today. I'm going to move myself over here. Yeah. Okay, now let's set up our project. Let's quickly set up the project. I will set it up for me alone. I really want to show you some hooks to do the advanced stuff too, or the more advanced stuff too today. So we'll go over this quite quickly. It's quite self-explanatory. You just run the Amplify init command to initialize your project. And then you choose a name for your cloud environment. And then you also choose the profile and the credentials to use for this environment. So this connects you to a certain cloud account. And this tells Amplify which credentials to use when you run a deploy. Now, in an Amplify environment, that's a totally separate environment, a box of that contains all your services that you have configured within your project. You can set up many environments like this, which are kind of like copies or of the application, totally separate from each other. Now, once you have initialized your environment, you can add categories to this. You can add an API to it. You can add Lambda functions. You can add authorization. And then you push your changes towards the cloud. So it is initialize your project, add some categories, and push the changes towards the cloud, which will deploy the cloud services for you. Now, when you do this, and this is interesting, an Amplify folder will be generated, and this Amplify folder contains some subdirectories, of which we see 3 over here. And we see the .conf directory. And this directory actually contains some configuration for the current environment, but also for the other environments, telling Amplify which profile and thereby which credential to use for which environment. And then we have 2 directories regarding our backend. We see the current cloud backend directory and we see the backend directory. Now, the current cloud backend directory, the name says it all. It contains everything that is currently deployed within our cloud and within our environment. The backend directory, however, contains everything that we want to be deployed in our account. Now, when we run an Amplify push, when we push changes towards the cloud, Amplify will compare everything that we want to be deployed, so the backend directory, with everything that is already deployed, so the current cloud backend directory, and based upon this, it will start updating the CloudFormation stacks in your account. Now, if you're using VS Code, and many of us do, then by default in settings.json, you will find the configuration to hide those files, those folders from you. Now I say remove the configuration and show those folders, because it will teach you and it will help you get a feel for how the framework works. And at some point, you will need to understand it. Now, we just set up our backend services. We pushed everything that we wanted to the cloud. Now we also want to use those things in our frontend. So I heard frontend. I heard full stack is dead. Is full stack really dead? I don't know. We just pushed something to the cloud for our backend, and now we're going to configure our frontend. It's not that right. Here you see the AWS exports file, and the AWS exports file is a file that is updated when you push your backend changes to the cloud, and contains all the information and all the service endpoints that your frontend needs to know about to communicate with your backend. So it will, for example, and you see it here, it will contain your GraphQL endpoint to which your frontend can send its GraphQL post requests. Now, this AWS exports file is automatically filled in for you. And then you have to use it within your application. Here I'm using it in a React application. So I am importing the configuration. And then I am using the Amplify components from the Amplify library. And they now know how to connect with our cloud, because we gave it the configuration from our cloud account. Now, we set up our project. Let's now start working in a team, because everything I have done so far, I have done alone. And that is not the purpose. We want to work as a team, but still we want a separate developer environment per developer, so that every developer can work separately implementing the feature that he's working on. Now, we already saw our cloud accounts, and we saw that we have multiple accounts in our organization. So in our dev account, we want to create those separate environments for all of our developers. Now, how will we do that? Well, it's easy. Amplify. What do I want to do? I want to add an environment. So Amplify env add. This means adding a new environment, giving it a name, for example, devnik, this is my environment. And then it will ask you to choose the profile to use in order to have the credentials to create and push this environment to the cloud. Now, you can do this for all of your developers within your team. You can even make separate environments for every feature that you want to implement, and also separate environments for your test environment and for your production environment. We will see that later. But when you add those environments, you will see a new file show up, which is the team provider info.json file. And that file actually contains information of all the environments that exist. So here I opened that file, and within that file, we now see that there is a dev environment, there is a devnik environment, there is a devn environment. And now I made it smaller here, but within these files, you will find information for CloudFormation, how to connect to those environments, which stacks to use for the specific environment. Now, a mistake I sometimes see in a community is when you make something for the community, then you should not commit this file. Because even if you have created multiple accounts, multiple environments, maybe across multiple accounts, the people across the world from the community that will check out your code, they won't have access to your cloud account, so they won't be able to push to your environments. But you, in your team provider.info.json, you mention that those environments actually exist, but for these people, they don't exist because they don't have access to those environments. But if you're working in a team, then you really need this file to work together. Now, we added separate environments for our developers. Now, let's make this setup ready for production, and let's also create new environments, the test and the production environment on other cloud accounts. So we're actually going to follow the same process here. Now we just want to add environments in other accounts, the test account and the production account. So we are going to, again, run amplify env environment add, and then we're going to push that environment to the cloud. Only now, when we are running amplify env add a new environment, we're going to choose a name for the new environment. And we are also going to choose an AWS profile. And now we choose a profile that contains the credentials to connect to the test account in this case. So this environment will actually be set up on another cloud account, which is the best practice. You can do the same thing for production, and now you have your developer environment on your dev account, you have your test environment on your test account, and you have your production environment on your prod account, as it should be. Now, let's start implementing our first feature. Nice. We want to implement the first feature. Let's see how we do that. What's the Git flow that we follow? What feature will we implement? Now, we were building this quiz application, and people can make questions there, but people who have bad intentions, they can also create inappropriate questions. So we want to enable flagging inappropriate questions. So this is a feature, enable flagging of questions. And for this, we will need to create a Git feature branch, and we will also need to implement these changes on a Amplify environment. Now, Amplify environments and checking out an Amplify environment is not the same, and it's actually independent of Git branches and checking out a Git branch. It's something that can be confusing at times, but you can have a different Amplify environment which actually contains the content from the same Git branch and vice versa. So they can be totally separate of each other. In a good workflow, of course, you use them together to build the right workflow. Now, this workflow, you need to follow along with me here, because when I first tried to set this up, I was really confused. So let's now say that N, she's going to implement our feature. She's going to enable the flag question feature for us. So it will be developed by N. Now, N, she decides to check out a new Git branch from master, as she should, indeed. Well done. And then we know that Anne has our own developer environment of Amplify. So she's also going to do the work on her own developer environment in the cloud so that all the developers can work on other features and other Git branches. So she checks out her own environment. She makes sure that she's on her own environment. Then she makes sure that she has deployed the latest version of the application to her environment. So she runs a push to update the environment in the cloud with the latest changes that are on the feature branch, which is actually coming from master. And then she starts implementing the feature. She updates the API, she adds a Lambda function, she makes some backend changes, some front-end changes. She does a lot of work. And she also runs an Amplify push to push her changes to the cloud. Now, those changes are being deployed in her Amplify environment. So only on the dev on environment. Now, yeah, so on finishes the changes and she opens a pull request or a merge request, depending if you're on GitHub or GitLab. And then I will start validating it. So now I also have my own environment. So what I do is I go on Git, I choose the right Git branch. So I check out the feature branch, which contains the changes for the flag question implementation. And then I check out my own environment, and then I push all of the configuration that is on the feature flag question branch. I push those changes to the cloud, to my environment. I test it, I validate the code, and I approve. And at that point, we can merge the feature into master. All right. That's great. So we have merged the feature into master. Now we also want to deploy the feature to our dev, test, and production account. And we want to be lazy and we want to do the same thing all the time. So we are going to use a CI/CD pipeline to do the work for us. We're going to automate our workflow. So what's the challenge here? We don't want to run Amplify push from our local machines all the time. No, we want to use an Amplify push command. We want to deploy Amplify changes in our CI/CD pipeline. And we call it a headless deploy. Because if you run Amplify push from on your own machine, it will ask you, it will look for the configuration on your machine. It will ask you a couple of questions. No, we don't want that on our automated workflow. So that's why it's called a headless deploy. Now, what does that mean? How do we configure that headless deploy? Well, let's look at that, how I do it using GitLab and Amplify. So we're going to use a GitLab pipeline here. And we're seeing that in the configuration of that pipeline, I say, okay, when we want to deploy to the development environment, I want to do that when someone is merged to master. And then I want to do the following things. I have my credentials configured in GitLab. And now I want to configure the AWS CLI and the Amplify CLI to use those credentials. Those are the first 3 lines. And then you see me running an init, which is actually loading the configuration. And then you see me running a publish or a push, which is pushing the changes to the cloud. Now, the good eye has also seen that there is an environment variable in there, which says CI is false. Now, you shouldn't need this environment variable. Most CI/CD pipelines, or if you deploy a front-end application in a CI/CD pipeline, it will have the CI environment variable on true, which means that warnings will be treated as errors. So if your code produces a warning somewhere, it won't deploy your changes. Now, we're looking into the init script here. So I told you we're running an init of the environment. It's not important to get into the details here. There's one important line here, and that is where we say, okay, we want to initialize our Amplify environment with the right configuration. And that configuration is what you see in the background. After we have configured and we have initialized that environment in our CI/CD pipeline, we can now push or publish the changes to the cloud. Now, what's the difference between publish and push? Publish will also publish your front end. So we will publish the front end and implicitly also run a push deploying our cloud backend changes. You can also choose to run a push only, just change the publish here by push. But okay, this is the important command here, publishing the changes. So we learned how to set up the environments across multiple accounts, environments separate for developers. We saw how we can use a CI/CD pipeline to deploy our changes. Now I want to get a little deeper into the services of Amplify. And one of those services, and one that you see a lot out there, that's the API service, which uses GraphQL, or it doesn't have to use GraphQL API, but most projects do, and also mine does. And for when you set up a GraphQL API, you're actually using the AWS AppSync service underneath. So let's learn a little bit more about that. And mind, we are still implementing that feature here, flagging questions. We want to flag inappropriate questions. Let's see how we can update our API to support that. So a little more about GraphQL and AppSync. So GraphQL, you can see there's three main pillars. And within your GraphQL API, you have, on the one hand, you have the schema. The schema where you define the data that you can fetch and the operations that you can do on that data in your schema. So in our case, we have a question, and we also have users, and so we can query for all users, but we can also update some data, we can mutate some data. And here you see it, we want to make a new mutation, the flag question mutation. So it's a mutation, it will adapt some data in the cloud. We call it flag question, and it will return us a question object, the updated question object. Now, okay, we define everything that we can do in our schema. Now we actually want to do something, so someone needs to do the work for us. If we are asking the API to do something or to give us some information, someone needs to know where to get that information. I want to solve this question. I have gotten a query, and now I want to solve, I want to resolve, I want to give an answer to the question. So here in AppSync, these are the mapping templates which are pointing us towards the right data source to get our data or to make our updates. And you see here, those data sources is actually where our data lives. And that data can come from, on the one hand, DynamoDB table directly, or it can come from a Lambda function, which can or cannot connect to a DynamoDB table or others. These are actually not the only data sources, but these are the ones that I'm discussing here. So, reminder, we have the schema. We ask some information from the schema. So we need to solve that question. We need to solve that query. We need to resolve that query. And we need to go and fetch the data from our data sources. Here again, you see those same three terms. We want to get a question. We want to get some information. We want to get that specific question. Okay, where do I need to get that question? That's in the VTL template. How am I going to get that information? That's actually pointing me and telling me what operation to do on the data source, which in this case is the question table. Here you see the same thing for a Lambda function. So I want to flag a question. I just want to pass along the payload towards the Lambda function that I am invoking. We can get deeper into this, but we're not going to right now. We're just passing on the payload. We're saying which field we're resolving. We're saying on which type we are resolving this field. We're passing that information towards our Lambda function, which will do the work for us and will return the updated question to us. So let's update our schema now, our GraphQL schema, which is defined in the file schema.graphql. And we see the type, the question type there, which was already there. And we also, now we need to do three things. We need to add a type mutation because we want to do a mutation. Which mutation we want to do? We want to do the flag question mutation. Now, then we need to define how are we going to resolve this mutation? What are we actually, where is the logic that we want to execute when we're calling this mutation? Now we want to use a Lambda function for that. Which Lambda function? We want to use the flag question Lambda function, which will be automatically suffixed by our environment here. Now, okay, we defined this new mutation in our API. Let's now also add that flag question Lambda function. Now, okay, that's, we do the amplify function add command. And then we choose the right name for our function. Mind, I choose again flag question here because previously, you see here in my schema, I also told it that the function is named flag question and to be automatically suffixed by the environment. Which runtime is it? Yeah, it's Node.js, and I just choose the template. I will edit this later anyway. So we saw how we can add a new mutation and how we can add the resolver that will actually do the logic, execute the logic upon this mutation. Now, that Lambda function that we just created, that needs to do a couple of things. And we need to configure that Lambda function correctly. There are a couple of things which I call the art of configuring your functions correctly with AWS Amplify that are very good to know when setting up Lambda functions with AWS Amplify. I'm going to move myself to the bottom again here. And those 5 good to knows, they are about permissions and policies. How do I give my Lambda function the right permissions to access other resources within my cloud without those permissions being overwritten by changes that the Amplify CLI makes automatically? How do I set up environment variables for my Lambda functions? How do I use Lambda layers the best way? How can I call my own AppSync API from within my Lambda function? So I want to call the API GraphQL endpoint from within the Lambda function. And then how can I use, or how can I correctly handle errors, mostly functional errors that I often see people just throwing. But if you just throw if you just throw something because you want to return a certain message to the front end, you're just throwing it because you don't know any other way of returning it to the front end, but there actually is another way. And then you won't mess up all of your metrics because it's not really an error. You're just throwing it to return the error message to the front end. Okay, first up, permissions and policies. Now, you can configure part of this using the Amplify CLI. You just run amplify function update, and then it will ask you, do you want to give this function permissions to other cloud resources that I know of? You can say, yes, please give me the permissions to access those resources. But what if you need more? What if you need access to the SSM service, for example? Now, then you need to update your CloudFormation template, the CloudFormation template of your Lambda function. And you find this in the backend directory, then in the functions category. And there you find all of your Lambda functions, and each of those functions has a CloudFormation template. And in that template, you can configure, you can set up the correct policies and attach them to the role of the Lambda function. Now, don't add your policies to already existing policies in there, or don't name them, don't use the same name as the policies already in there. No, just add the policy with your own name, with the name that you choose yourself, so that it will not be overwritten by the changes that the Amplify CLI makes automatically. Okay, next up, environment variables. And this one can be a little tricky, and it actually depends on the situation. Do I need an environment-specific environment variable, so a variable that's different on production and on tests? Do I need a variable that is always the same, but is only used in one function? What I choose mostly, if I need to set up environments that are environment variables that are different across different cloud accounts, production, test, dev, I set up these environments in the parameter store in the SSM service, and then in my CloudFormation template, I am resolving that environment variable from the SSM service. Now, if you do this, mind that you also have to give your Lambda function the correct permissions to access the SSM service, of course, which is step 1. And then you can find your environment variables from there. Lambda layers. Say we want to use Lambda layers. We're going to look at two options. The one where we're actually defining a layer ourselves within Amplify, and the one where we're using an external public layer, like here I'm using the Lumigo layer for tracing and for observability within my cloud. Now, okay, let's first look at our own layers. You can actually add a layer in Amplify. You use the Amplify add function command, and then you choose to add a layer. And in that layer, you can add your code and the code that you want to share across multiple functions. Now, if you follow the standard way there, the standard Amplify way, it will become quite messy to know what version to use on which environment. So I just prefer to use the layer ARN, which is always pointing to the latest version of the layer on a certain cloud environment. So you don't have to worry about the versions anymore. That is, of course, if you want to use the latest version all the time. But this really, using this ARN really simplified my life, because before that, it was tedious. Now, okay, second case, say we want to use an external layer, the Lumigo layer in this case, then I just add the ARN pointing to the layer, to the CloudFormation template of the Lambda. Next up, calling your own GraphQL, your own AppSync API from within your Lambda function. So first, again, permissions. Your function needs IAM permissions to access your GraphQL API. Next, you have to set up a client, GraphQL client. Here I'm using the AppSync client, and I'm telling the AppSync client, okay, for authorization, I'm going to sign this request with my AWS IAM credentials. And here you see the code, here you say the way of doing that actually. So if you use this code to authorize your calls, the permissions from your Lambda function will be used to make the call to the AppSync service. And then, last but not least, error handling in a Lambda function. Now, say a function or a question also needs to be approved before it is published to all users. Now, maybe somewhere I want to do an action, but I don't want to do that action on a question if the question is not yet approved. So what I often see then is people just say, okay, throw error, this question is not approved yet. And what that will do is it will return, this question is not approved yet, to the front end. But it will also throw a real error in your Lambda function, which means that it will mess up your metrics because it will look like all of your Lambda functions are crashing or are throwing errors. It will make monitoring very much difficult because now your real errors are actually hidden within all of those fake errors that are just used to return messages, faulty messages to the front end. So what you can do instead of that is you can also return an object from your function which contains an error message and an error type. And then your resolver will also pass that response back to the front end, and the front end again gets the message, is able to display the message, but in your function you did not have to throw an error. So no fake errors in your monitoring, no fake errors in your metrics. All right, nice. We implemented this feature. Everybody happy? Let's see what we learned from that. Let's see what we saw on our journey. We saw how we could set up an Amplify project across multiple environments and even across multiple accounts. So really a production-ready setup. We saw how we can use the Amplify headless deploy in our CI/CD pipeline. Next, we dove a little deeper into the GraphQL API and how to create a GraphQL API. What are the pillars of such an API? And then we saw 5 good to knows for setting up and configuring your Lambda functions. Now, all right, then I want to thank you for embarking with me on this journey through the world of Amplify. I share with you my learnings, which will make you stronger in the future. And if you have anything more to ask or you want to view more content, look for me on the following channels, especially on Twitter. Ask me anything there, and I will get back to you. Cheers, guys. Bye. Hi, Ger.
Hey, Nick. So yeah, I have an eye on the questions. There are none yet, so let me quickly ask one myself. I'm not that familiar with Amplify, but I hacked my way around a little bit and use it with Go. But can you tell us when should we have the reflex to use Amplify? Maybe when we should not use Amplify. So which are good use cases for Amplify and which are not?
Yes, so it's often advocated as a front-end first framework. So for the front-end developers to get in there, to get started working with cloud, and to make onboarding into cloud easy. Now, there are a couple side remarks to make there, because of course, if you have no cloud knowledge, it will, and with Amplify, it will be very smooth and easy to set up your first cloud application. Until you have to go that step further, and then of course, you need to start building that cloud knowledge. But of course, Amplify will help you build it gradually. So you cannot learn the cloud at once. Some people say, it's not good because you will have to learn so much at once. That's not true. It will build and it will grow with you. It will actually help you get started very quickly. Or also to prove your concept, for example, you can, because it takes so much work out of your hands, you can really set up an application, front-end and back-end, fully scalable, really in a matter of days and weeks if you know what you're doing. But then to answer the second part of your question, when to not use Amplify, I think you need to very well understand what it is made for. For me now, that's web applications with it mostly on top of an API. sometimes offline first. That's not my cup of tea. But if you want to do a lot of things with Kinesis or data, streaming applications, then you probably want to look at another solution.
Okay, fair enough. And language-wise, I think it heavily depends on JavaScript, or do I see that wrong as well?
I've actually only used it with JavaScript. But yeah, of course, your Lambda functions you can write in any Lambda runtime that is provided by AWS. But then the Amplify CLI and the Amplify libraries for frontend, of course, those things, they are JavaScript.
Yeah. Okay. I don't see any questions yet. Maybe another one from me then.
Right.
Cost-wise, is it a cheap? Is it something that is cheap or expensive? Or of course it depends on the use, but you have a lot of services which just doesn't cost anything as long as you don't use it. Is it the same for Amplify?
Yeah, it's working mostly with serverless services, unless you use the Elasticsearch within it. But we haven't used that, and we've actually paid up until now, the first 6 months of our startup, we have paid $0 to AWS.
Okay. Cool.
Yeah.
Cool. But then maybe elaborating on the previous one, do you think that then, say you start with Amplify because it gives you a head start, and then at some point you feel like you have gained a lot of knowledge and you want to maybe transition to something differently on AWS? Would that be possible? Would that be easy?
I have not done that. I have heard people saying like, okay, I will build it with Amplify. Then it gets, I really want to do a lot of tricky things and custom things. I will use the CloudFormation that was generated, and I will use another framework. Now, for the moment, we are already doing a lot of operations on our API. We're having a broad platform, and Amplify still can fully support it. They offer a way out if they don't provision it out of the box. You can also write your own CloudFormation, and you don't have to use all of the generated resolvers, for example, for your GraphQL API. If you want to use a Lambda function as a resolver, you just need to look up the documentation and see how you can configure that. You can actually do a lot more with it than just the getting started tutorials. Or we see a lot of tutorials out there for advocacy, which is great because it's a great tool, but they only go so far. And then you can actually go a lot further, but the resources, okay, the YouTube videos about those things, they're scarce, but the documentation is really well, and there is a very good Discord channel where people are really motivated to help each other. And on top of that, I also think that last year, Amplify was in the top 5 fastest growing GitHub projects. So the community support is really strong at the moment.
Oh, cool, okay. I don't see any other questions pop up, so I think we can call it a wrap for this evening. So yeah, on the other hand, I hope everybody has enjoyed our 2 talks, and next one will probably be online as well. Nick is normally our host, but he was giving a talk today, so I was the master of ceremony this time. But yes, stay tuned.
You can go again next time.
So yeah, keep an eye on our Meetup, Twitter, LinkedIn for our next one. So have a good evening.
Cheers, everybody. Bye.
Bye.